podcast is brought to you by LMU Munich.
Let me start with a phenomenon that cuts... Oh, by the way, there's a handout. So, are there any more handouts? I think so. Everyone, I don't have slides, so you're going to need the handout. So let me start with a phenomenon that cuts across the semantic paradoxes, whether a paradox of definability or a version of Russell's paradox or the liar. The phenomenon is this: given a paradoxical expression, we can go on to produce an unproblematic expression composed of the very same words. So for example, suppose I write on the board these expressions, pi, 6, the sum of the numbers denoted by expressions on the board, and let's think about that third expression. Suppose the third expression denotes a number, say k, then we can reach the contradictory conclusion that k equals pi plus 6 plus k. So the obvious reasoning would lead us to, if we assume the third expression denotes k, then we find that k equals pi plus 6 plus k. So the third expression fails to denote a number. Only the first two expressions denote numbers. So we may truly conclude the sum of the numbers denoted by expressions on the board is pi plus 6. And here we've repeated the defective phrase and produced an expression that does denote a number, namely pi plus 6. Or suppose I write on the board these two expressions, moon of the earth, unit extension of a predicate on the board. The first expression has a well-determined unit extension. Suppose the second expression has an extension, say E2. The extension E2 belongs to itself or it doesn't. If E2 does belong to itself, then it has two members and so doesn't belong to itself. If it doesn't belong to itself, then it has just one member, so it is a unit extension and does belong to itself. Either way, we get a contradiction. So the second expression is defective and does not have a well-determined extension. In particular, it does not have a unit extension. So we may conclude the extension of the first expression is the only unit extension of a predicate on the board. And here we've repeated the defective expression, and this repetition has a fully determinate extension, namely the extension whose only member is the moon. Or, suppose I write on the board the following sentence. The sentence on the board is not true. This is a liar sentence, and it's semantically defective. So we can conclude the sentence on the board is not true. These discourses display apparently natural and intuitive reasoning, and any adequate response to semantic paradox should provide some account of them. So, call this phenomenon repetition. Though repetition is common to all the semantic paradoxes, it's the case of the liar that's received most attention. Consider Kripke's minimal fixed point construction. Kripke points out that one can truly say that liar sentences are not true. A liar sentence, like any ungrounded sentence, is never made true by the inductive process that leads to the minimal fixed point. So if we take our liar sentence on the board, this will be ungrounded, gappy, neither true nor false in the minimal fixed point. Consequently, we can say that the sentence on the board is not true. Kripke's own take on this is that this subsequent evaluation, that the liar sentence is not true, is expressed in a meta-language. So repetition is not genuine repetition. The object language liar sentence is one thing. The subsequent judgment that the liar sentence is not true is another, expressed in a meta-language. Suppose we take the minimal fixed point to be a model of natural language, then Kripke says the sense in which we can say in natural language that the liar sentence is not true would have to be associated with a later stage in the development of natural language where speakers reflect on the process that generates the minimal fixed point. This repetition is expressed by speakers who speak a meta-language containing technical notions such as truth value gap and groundedness. Field has suggested that there's a better way of understanding Kripke's theory. Field suggests that it is better to take Kripke's theory not as committed to truth value gaps, but rather as committed to non-classical logic. According to this paracomplete version of Kripke's theory, the law of excluded middle is not valid. In particular, given our liar sentence on the board, we don't accept it, we do not accept its negation, and we do not accept the disjunction of it and its negation. We should accept a thoroughgoing paracompleteness. We cannot say of the liar sentence that it's true, or not false, or gappy, or not gappy, or that there's a fact of the matter about its status, or that there's not a fact of the matter about its status. On this version of Kripke's theory, the phenomenon of repetition is illusory. It has us saying something about the liar sentence that we can't say. The law of excluded middle fails for the liar sentence, and we cannot say that it's not true. Although Field thinks that this is a better way to understand Kripke's theory, he regards it as a drawback that the theory doesn't allow us to assess the liar sentence. We do want to say that it's not true, in some sense of not true. According to Field, what is needed is a stronger notion of truth, so that when we say that liar sentences are not true, we're saying that liar sentences are not strongly true. In Field's own paracomplete theory, strong truth is to be understood in terms of a determinately operator applied to the Kripkean notion of truth. So that when we say that the liar sentence is not true, we're saying that it's not determinately true. And we can express the defectiveness of the liar sentence by saying that neither it nor its negation is determinately true. The notion of determinate truth in turn gives rise to a determinately true liar, a sentence that says of itself that it's not determinately true. We cannot say that this isn't determinately true on pain of contradiction, but we can say it's not determinately true. Iterating, we obtain a transfinite hierarchy of increasingly strong notions of truth and corresponding notions of defectiveness. Like Kripke's theory, Field's theory says that repetition is not genuine repetition. The liar sentence says of itself that it's not true. Our subsequent evaluation of the liar says that it's not true in a stronger sense, that it's not determinately true. The two sentences involve different notions of truth. Unlike Kripke's theory, Field's way of treating repetition does not involve any assent to a meta-language. The determinately operator is definable within the object language. But it does involve a hierarchy of stronger and stronger notions of truth. Okay, so I think these accounts make heavy weather of repetition. There seems to me a simpler way. Kripke's and Field's accounts suggest a difference between the occurrence of true in the liar sentence and the subsequent occurrence in the repetition. So let's fix the use of true in the liar sentence with a subscript, indicating its occurrence in the object language in which the liar sentence appears. Represent the liar sentence as L, the sentence on the board is not true alpha. If we suppose L is true alpha, we reach a contradiction. If we suppose it's false alpha and so not true alpha, we reach a contradiction again. So we conclude that L is neither true alpha nor false alpha, that L cannot be assessed by the truth alpha schema, that L fails to have truth alpha conditions. We can say that L is defective. It cannot be assessed by the true alpha schema. So we truly conclude R, the sentence on the board, is not true alpha. R is a genuine repetition. Both sentences are comprised of the same words with the same meanings and extensions. To capture repetition, there's no need to appeal to a shift to a meta-language or to split truth into different notions or to deny that we can say that L is not true. We just have a single truth predicate, the one we started with no change of extension. We represent the intuitive move from defective to not true in an appropriately simple way. It's the same story for denotation and extension. Okay, now I want to think about a slightly more complicated chain of reasoning. Suppose we reason in the following way. We carry out the following chain of reasoning. Since L is a liar sentence, L is defective. So 1, L is not true. Now we can form a new liar sentence building on 1. So call this 1 star, L is not true, and neither is 1 star. Okay, so this would be if you were given a sentence like 1 and 2 is 4, you can say that that sentence is not true. And given that sentence, it's easy to construct a new liar out of that by saying 1 plus 2 equals 4 is not true, and neither is this sentence. Okay, so given any innocent untruth, you can always add to that a phrase like, but this very sentence isn't. So to form a new liar doesn't take much skill, it doesn't require much by way of resources. You can always form a liar in that way. So moving from 1 to 1 star is the kind of thing that anyone who's become familiar with the liar can easily do. So 1 star, L is not true and neither is 1 star. 1 star is a new liar sentence, 1 star is defective. So too, 1 star is not true. But now, same thing again, we can form a new liar sentence building on 2. We can get 2 star, 1 star is not true and neither is 2 star. Since 2 star is a liar sentence, 2 star is defective, so 2 star is not true. And then we can keep going and construct new liar sentences, an unending sequence here, where we're just doing the same thing over and over again. Given a sentence that we say is not true, we just can append, but this very sentence isn't. Okay, so we can move on through a series of liar sentences, 3 star, 4 star, and so on. So if we're already familiar with the liar, we don't need much to carry out this reasoning. We just need to make the move from a sentence as being defective to its not being true, and we need to be able to construct new liar sentences. That's all we need, just the move from given something that's semantically defective, we move to its not being true, and the ability to form new liar sentences. These are all the resources we need. So in this chain of reasoning, we're doing the same thing over and over again. Now on the present simple account, true is represented by true alpha throughout. Saying that L is defective, we saw is to say that it does not have truth alpha conditions. From this it follows, 1, that L is not true alpha. So this will be the analysis of 1, L is not true alpha. We can now form the liar sentence 1 star. 1 star is 1 is not true alpha and neither is 1 star. That's the liar sentence. And in turn, 1 star does not have truth alpha conditions, so it's not true alpha, and that's 2, and so on. We use a single truth predicate that maintains the same extension throughout, and we employ a single notion of defectiveness, the failure to have truth alpha conditions. So just one occurrence of the truth predicate over and over again, and one notion of defectiveness. This captures the fact that as we reason along this chain, we're doing the same thing over and over again. No new resources are required. If we look at the other accounts that I've mentioned, like Kripke's and Field's, we get a much more complicated story. According to Kripke's account, 1, the sentence 1 in the sequence, belongs to a different language from L. In producing 1, we're speaking in a more technical meta-language that indicates reflection on the minimal fixed point. And the subsequent steps, presumably, as we go through these new liars and through that process, presumably we're carried through a hierarchy of further meta-languages. And this seems to attribute too much to us. Field's paracomplete version of Kripke prohibits the speaker from even producing 1 because the law of excluded middle fails for the liar sentence. But this seems to me to prohibit us from doing what we seem perfectly capable of doing. According to Field's own theory, 1 is to be interpreted as L is not determinately true alpha. So we've got a determinately operator attaching to the truth predicate. So in moving from L to 1, we move from truth to determinate truth. 1 involves the use of a stronger notion of truth. Now 1 star is L is not determinately true and neither is 1 star. So 1 star is a determinately true liar sentence. We cannot say that 1 star is not determinately true. The sense in which we can say that it's not determinately true is in terms of a still stronger notion of truth. So 2 is interpreted as 1 star is not determinately true. In turn, 3 is interpreted as 2 star is not determinately true, alpha, and so on. So in our reasoning here, we're being interpreted as implying a sequence of stronger and stronger notions of truth and notions of defectiveness that seem further and further removed from ordinary language. And Field does take these notions to be outside ordinary talk. The fact is, he says, that people rarely iterate determinately operators very far. Yet here we're being interpreted as iterating the determinately operator repeatedly. And this seems implausible given how few resources we need to carry out this reasoning. The reasoning repeats the same cycle of steps, and we don't have a reason to identify any especially increasing conceptual complexity. So it seems to me one wants to go with the simpler account of the moves that are made in that sequence. Okay, so let's return to L and R. On the present account, we truly conclude R. Yet R is an exact repetition of the defective sentence L. So both L and R are saying that L is not true alpha. But there's a clear difference between the contexts in which L and R are produced. In R's context, there is new information available, namely the information that L is defective. We are now assessing L in the light of its defectiveness. Thinking of context in a familiar way, in terms of common ground or conversational score, or as a set of presuppositions, there's a shift of context. We can say that R's context, unlike L's context, is reflective with respect to L. So we'll call R's context reflective with respect to L, indicating that in the context in which R is produced, it's part of the common ground, it's recognised that L is defective. So in general, we can identify a contextual parameter here. Given a context C and an expression E, we can ask whether or not in context C it's part of the information that presumed to be available, or part of the common ground or the conversational score, that E is defective. We can ask about the reflective status of the context C relative to expression E. Okay, so now we've truly inferred R, yet R cannot be evaluated by the truth alpha schema any more than L can. The truth alpha schema no longer provides the standard of evaluation in R's context. With the contextual change in reflective status comes a shift in the standards of evaluation. Called the new truth schema the RL schema, reflecting on the sentence L, RL schema, a standard of evaluation that incorporates the fact that L is defective. Here's the instance of the schema for R. R is true sub RL if and only if L is not true alpha. The right-hand side holds L is not true alpha and R itself is true sub RL. When we evaluate R as true, we're using a reflective truth schema, reflective with respect to L, a new standard of evaluation contextually introduced by a shift in reflective status with respect to L. So there is a shift in the extension of the predicate true because of a contextual shift that changes the standards of evaluation. So we might make a comparison with the predicates hexagonal or flat. If you've just said that Italy is boot-shaped, I can say that France is hexagonal and get away with it. But if we're concerned with detailed mapping of the coastline, I can't do that. The extension of the hexagonal shifts with the standards that operate in the given context. Similarly, or analogously with true, the standards by which we assess L and by which we assess R are different because of the shifting reflective status. There's no intrinsic difference between L and R. R is a genuine repetition of L, but the difference lies in the contextually determined schemas by which they're assessed. L itself can also be assessed by the RL schema. We can reflectively evaluate L as true sub RL. This fits the intuition that L is true because it's defective and so not true, and that's what it says. So we can think of L can be rehabilitated. It's not true alpha, it doesn't have truth alpha conditions, but it is true sub RL. Just because it isn't true alpha, and that's what it says. Now we can give the same account of repetition in the case of denotation and extension. In these cases too, the repetition is an exact repetition of the original defective expression. But the difference between them No intrinsic difference, but the difference between them lies in the schema by which they're assessed. That's why the defective expression fails to denote or have an extension, while the repetition succeeds. And again, we can rehabilitate the defective expression, we can assess it reflectively. Now, it's not initially obvious that true or denotes or extension is context sensitive. But that's not because reflective status is an obscure or hidden feature of a context. It's straightforward to say for any context whether or not that context is explicitly reflective with respect to a given defective expression. So it's clear that the context of R is reflective in that way because it's part of the information that's being used that L is defective. So it's just a matter of whether or not it's part of the common ground that the expression is defective. What makes the context sensitivity unobvious is that discourses that exhibit the context sensitivity of our semantic predicates are not everyday discourses. Most speakers of English do not engage with the semantic paradoxes. But once we do, we need only an ordinary grasp of truth or denotation or extension to produce the reasoning associated with repetition. And that reasoning, I've claimed, displays a shift in reflective status and the context sensitivity of true and denotation and extension. Okay, so that's reflection and different accounts of reflection, and I'm claiming that there's a simpler account and that it introduces the idea that truth is context sensitive. Okay, so far the contextual approach to repetition is compatible with a hierarchical account of truth or denotation or extension. On this kind of view, true RL has a wider extension than true alpha. But there's an alternative that I want to sketch now. The alternative does not stratify truth into levels. Rather, a particular use of true is minimally restricted, applying globally except for certain singularities where its application breaks down. These singularities of true vary with the context. This singularity theory is in the spirit of a tantalizing remark of Gödel's. In the course of rejecting Russell's hierarchical account, Gödel says famously, it might even turn out that it is possible to assume every concept to be significant everywhere except for certain singular points or limiting points, so that the paradoxes would appear as something analogous to dividing by zero. Such a system would be most satisfying in the following respect. Our logical intuitions would then remain correct up to certain minor corrections. This is still Gödel, i.e. they could then be considered to give an essentially correct, only somewhat blurred, picture of the real state of affairs. So Gödel's remark suggests a way of dealing with the paradoxes in a way that minimises logical revision. The singularity theory applies this idea to truth, denotation and extension, suggesting that a use of a semantical predicate in natural language has singularities determined by the context. Okay, so consider again the liar sentence L. How should we represent L? Well, we can represent it by an ordered triple. The first member, type L, is the type of the sentence. The second is the way that we represent the occurrence of true within the sentence L. And we're representing that as true sub alpha, so the second member is alpha. We also need, though, a third member to capture L when it appears and when we're assessing it, and when it reveals itself to be defective. We need to know what standard of evaluation is being applied to it in its context of utterance. And there we apply the truth alpha schema and we get contradiction. So the representation of L is type L alpha alpha, where the third member indicates the schema by which it's being assessed in its context. Okay. The repetition R is the first two members are the same because it's the same type. So we can call it type L. And the second member, also the occurrence of true in R, is being represented by true alpha. so the second member of its triple is alpha. But the schema by which it's assessed in its context is the RL schema, so the third member of the triple is RL. So the representations of R and L share the same two first members. These shared members reflect the fact that R is a genuine repetition of L. But the third members differ since the standards of evaluation in the context of R is different from those operating in the context of L. The schema associated with R is the truth RL schema, which is reflected with respect to L. Okay, now the representation of L as I just have it as type L alpha alpha captures the schema by which L is assessed in the repetition discourse. We're going to call that the primary representation of L. L can be assessed by other schemas, of course. We can assess it by other schemas, but we're primarily interested in the schema by which it's initially assessed in the course of the repetition reasoning. So we're going to call that the primary representation of L, and the primary representation of R is going to be the triple type L alpha RL. Okay, so the main task of the singularity theory is to identify singularities of a given occurrence of true. We're going to understand by a sentence type in a context. Let the determination set of a given sentence S be the set of those sentences to which S makes reference. If I say everything Max says is true, the members of the associated determination set are the things that Max says. In the case of L, what's its determination set? It's just the unit set containing L. The primary tree in the general case for a sentence S is constructed as follows. At the top of the tree is the primary representation of S. So let that be type S beta gamma. At the second tier are representations of the members of S's determination set, those sentences that S makes reference to. Where the third member of each of these representations, notice, is going to be beta, because the members of this determination set are evaluated by the occurrence of true that's in S, and we're representing that by true beta. Similarly, at the third tier, representations of the members of the determination set of sentences that are represented at the second tier. And the third member of those sentences at the third tier will depend on what's in the second place of the sentence at the second tier. Now, in the case of L, what does the primary tree for L look like? Well, we start with its primary representation, type L alpha alpha. Then we go to the members of its determination set. Well, that's just L. And so the second member at the second tier here, alpha, is there because that's how we're representing true in L. And we're going to bring down the second member of the top triple, which is alpha, the occurrence of true in L. And that's going to be how we're going to assess the representation at the second tier. So it's going to be the same thing all the way down. Okay, so we're going to get a tree which is single branched and the branch is infinite. This indicates the semantic pathology or the defectiveness of L. And what the tree displays is that L cannot be assessed by its associated schema, that is the alpha schema. In general, if the primary representation, so of a sentence S, so type S beta gamma of a sentence S, if that primary representation repeats on an infinite branch of S's primary tree, then S is defective. And it's a singularity of true gamma, because that's the schema that was being used in the attempt to assess it. That led to pathology as revealed by this infinite branch, and so it's going to be a singularity of true gamma. It's not in the extension of true gamma. In particular, L is defective then, and a singularity of true alpha. According to the singularity theory, if S is a singularity of true alpha, then S is excluded from the extension of true alpha. So L is excluded from the extension of true alpha, so it isn't true alpha, just as R, the reflection on it, says. In contrast, the primary tree for R starts with the primary representation of R, type L alpha RL, we look at R's determination set, that's the sentence L, so we represent L at the second tier, and that's going to have, that representation will have as its third member the second member of the primary representation of L, because R is assessing L via true alpha. That's what R has occurring in it. Okay, so we get type L alpha alpha at the second tier, and now we keep going with L, and that will keep repeating. But the primary representation of R does not repeat on this infinite branch, so R is not defective. R stands above the loop in which L is caught. Unlike L, R can be assessed by its associated schema, the RL schema. R is true sub RL. So this provides the account of repetition. In the same way, in the cases of denotation and extension, primary trees lay out the defectiveness of the expressions on the board, so the primary trees are what are doing the work, and identify those expressions as singularities of the occurrences of true and extension on the board. We can consider more complicated cases, loops and chains, Nixon-Dean type loops, Curry's paradox, and so on. In each of these cases, infinite branches on the primary trees indicate defectiveness, and singularities can be read off the tree. Okay, so suppose that Max produces the liar sentence L. Suppose you say in some neutral context, everything Max says is true. A leading idea of the singularity theory is that anything that can be counted as true from your neutral context should be counted as true. Restrictions should only be placed on an occurrence of true when they have to be. A use of true is as global as it can be. So think of yourself as omniscient, able to view all the sentences that can be counted as true from your context of utterance. In your neutral context, where you're not looped or in any way tangled with Max's utterance, you're saying everything Max says is true, and you're not tangled with anything Max says, you can view Max's sentence reflectively. You stand above the loop in which Max is caught, and his utterance counts as true in your context of utterance. That's something that you can see as this omniscient being from your neutral context. The situation is captured by the primary tree for your utterance. Call your utterance U. Its context of utterance, call it CU. Now consider U's primary tree. The representations at the second tier are representations of the sentences in U's determination set. The third member of each representation will be C sub U, since your assessment of Max's utterance is via the CU schema. In particular, the representation of L is the triple type L alpha C sub U. This isn't the primary representation of L, it's what we can call a secondary representation, and at the third tier and each tier beyond, the primary representation of L repeats. So there's an infinite branch of U's primary tree involving L. U's primary tree branches out to all the members of its determination set, but this particular branch will be an infinite one involving L. So here, the primary representation of L repeats, indicating that L's defective and can't be assessed by the alpha schema. Accordingly, L's a singularity of true alpha. But the representation type L alpha C sub U, that representation above it does not repeat, indicating that L can be evaluated by the C sub U schema. L is not a singularity of true sub CU. So your evaluation, even though it's neutral, is treated as a reflective evaluation. Your neutral context is treated as reflective with respect to L. So this is in line with the idea that an occurrence of true should be as global as possible. The extension of true should be as global as possible. The context of U is reflective with respect to L, even though it's not explicitly part of the common ground or conversational score that L's defective in your neutral context of utterance. So there's no explicit recognition in your neutral context that L's defective, but it's treated as reflective because of the semantic connections that are laid out in the primary tree. In particular, that your neutral utterance stands above the loop in which L is caught. So this is the primary tree indicates that your evaluation of L stands above the circle in which L is caught. Your evaluation of L via the C sub U schema is not caught in paradox. In general, given an expression A, suppose that A's context is reflective with respect to an expression E. The reflective character of A's context can have two sources. It can be explicitly reflective because it's part of the common ground of A's context that E is defective, or it can be non-explicitly reflective in virtue of the nature of the network connecting A with E. This network's displayed by A's primary tree. In the case of your utterance U, for example, U's primary tree shows that U stands above the circle in which L is caught. So there's two sources for the reflective character of a context. One is where it's explicitly reflective and part of the common ground or the set of presuppositions that a certain sentence is defective. But as in the case of your neutral utterance here, its reflective character, the context reflective character, can be a matter of the network that connects your utterance with the utterances in its determination set. So the singularity theory makes minimal assumptions about the nature of contexts. It does assume a feature of explicit reflective status. That is, it assumes that it's a determinate feature of a context whether or not it's reflective with respect to a given expression. And that, again, is just a matter of whether it's explicitly part of the common ground that a given expression is defective. Beyond that, singularities of true are identified not by vague or ad hoc pragmatic principles, but rather by the semantic interrelations between sentences as laid out in the primary trees. So the overall picture is this. True is a context-sensitive predicate that undergoes minimal changes in its extension with shifts of context. Each occurrence of true is as close to global in its application as it can be. No occurrence of true is fully global. If you say snow is white is true, it's always possible to produce an anaphoric liar paradox that we've already noted by adding, but this very sentence isn't. It's sometimes complained that hierarchical versions of contextualism about truth have no systematic way to attribute level to a given utterance. This isn't a complaint that can be levelled against the singularity theory, I think, because truth isn't stratified. Rather, it's a matter of identifying the singularities of a given occurrence of true. And for that, we need only the notion of the reflective status of a context, either given explicitly as a feature of the context or given via the semantic connections displayed in the primary trees. So, for example, your utterance U, when you say everything Max says is true, is not associated with any level. Suppose that your utterance is not paradoxically tangled with any of Max's utterances, then each of Max's utterances is assessed by the CU schema. None of what Max says is a singularity of your use of true. The notion of a level does not enter in here. All that matters is the identification of singularities. And as we've seen, even if Max produces the liar sentence L, this too is assessed by your neutral CU schema. There's no need to exclude L or any of Max's utterances from the scope of the true U predicate. Now, disquotationalists about truth have emphasised the intersubstitutability of S and S is true, and the expressive role of truth, its role in expressing generalisations that we couldn't otherwise express. So your utterance U is equivalent to the infinite conjunction if Max says S1 quoted then S1, and if Max says quote S2 then S2, and which in turn is equivalent to SK1 and SK2 and SK3 and through to SKN, where each of the SKIs is one of the things that Max says. Again, assuming that your utterance U is not paradoxically tangled with any of Max's utterances, the singularity theory is fine with all this. Any of Max's utterances is intersubstitutable with the assessment of them by true sub U. So SKI in general is going to be intersubstitutable with true sub U SKI. But there are limits to the intersubstitutability principle. Consider again the liar sentence L, represented as L is not true alpha. Consider L and L is true alpha. So we've got L and we're saying that L is true alpha. Consider those two sentences. Consider a reflective evaluation of these. For example, consider the evaluation of these, say, by your true U schema. Now, L is true sub U. But L is true alpha is false U, because it's not the case that L is true alpha. It fails to have true alpha conditions. So here, the intersubstitutability principle fails. So we need to restrict the truth schema. Once we have the notion of a singularity on board, we can provide a minimally restricted truth schema for an occurrence of true tied to context alpha. So if S is not a singularity of true alpha, then, and then we have the biconditional, S is true alpha if and only if S. So singularities aside, intersubstitutability holds, and it's a similar story for denotation and extension. Okay, the phenomenon of repetition shows that we can use our ordinary truth predicate reflectively. We can assess defective sentences in the light of their defectiveness. And reflective uses of truth and falsity show that truth is not disquotational. The truth predicate of Kripke's fixed point is disquotational, but this truth predicate is not the truth predicate of natural language. Field takes Kripke's disquotational truth to be truth. Assessment of liar sentences is assigned instead to stronger notions of truth constructed out of Kripke's truth and the determinately operator. But I've argued that this departs from natural language where no departure is needed. We assess defective sentences using our ordinary notions of truth and falsity. Okay, so let me turn to the final topic, talking particularly about revenge. So, any attempt to come to grips with the semantic paradoxes faces revenge. Repetition presents one form of revenge. So, I've really been talking about revenge already because you can think of repetition as providing one form of revenge where the liar comes back, or it appears to come back as something you assert. In the case of the liar, the very words of the liar sentence re-emerge as something we can truly assert. A second form of revenge generates new paradoxes from the very terms of the purported solution. In the case of Field's paracomplete theory, for example, there's the thread of new paradoxes that emerge from Field's determinacy hierarchy. We have a hierarchy of distinct truth concepts, determinate truth, determinate truth, and so on, each with its own correlative notion of defectiveness. Now, it seems reasonable to suppose that we have a general notion of determinate truth and a general notion of defectiveness, but on pain of paradox, such notions can't be expressed. In general, revenge presents a familiar dilemma: accept expressive incompleteness or accept inconsistency. So we might embrace inconsistency for the sake of expressive completeness, but I think there are revenge paradoxes even for the dialetheist. So I'll consider the following version of dialetheism. There are only two truth values, true and false, and different sentences relate to these values in different ways. Some relate consistently, some relate inconsistently. Now, it's natural to think that a revenge liar for the dialetheist is generated by the sentence X says of itself, X is false only. X is a liar sentence, so according to the dialetheist, it is both true and false. Since it's true, X is false only. So X is both true and false only. And now we might claim that X cannot be both true and false only, but the dialetheist has a response. By dialetheist lights, being true and false does not preclude being false only. That X is false only is additional information, additional to the information that it's both true and false. The dialetheist will say that we can capture the status of X by this semantic profile, Tx and Fx and not Tx, where the third conjunct simply adds more information and doesn't take back the truth of X. So we need to go beyond the false-only paradox. So let me suggest one purported revenge, and Graham can tell me where it doesn't really pose a problem. Okay, so define the value set of a sentence S as the set of S's values. The value set of 2 plus 2 is 4 is the unit set containing 1. The value set of 2 plus 2 equals 5 is the unit set containing 0. The value set of the liar sentence X is 1, 0, set containing 1, 0. A sentence can have only one value set. Non-paradoxical sentences that are true have the value set 1. Non-paradoxical sentences that are false have the value set 0. And paradoxical sentences have the value set 1, 0. If a sentence is paradoxical so that its value set is 1, 0, we can at least say this about S, TA and FA. But this may not be its complete semantic profile. There may be more to say about A. A may also be, for example, untrue or false only. But A's value set will still be 1, 0. For example, the value set of X is 1, 0, even though its semantic profile is TX and FX and not TX, where there's a conjunct beyond TX and FX. In general, no conjunct of a sentence S's semantic profile other than TA or FA can contribute to the value set of S, although further conjuncts may contribute to its semantic profile. If S is paradoxical, its value set is 1, 0. A's value set, if A is a paradoxical sentence, cannot be smaller or larger. But its semantic profile may go beyond just TA and FA. It may include not TA. So now consider the sentence Y, the value set of Y is 0, or the unit set containing 0. Suppose first that the value set of Y is 1, so 1 is true. By the truth schema, it follows that the value set of Y is 0. Since any sentence has just one value set, it follows that the unit set containing 1 equals the unit set containing 0, and so 1 equals 0, and the result is triviality. And that's unacceptable to the rational dialetheist. Suppose second that the value set of Y is 0, then by the truth schema, given what Y says, that its value set is unit set containing 0, Y is true. So if Y is true, its value set is either 1 or 1, 0. Either way, 1 is 0, 1 equals 0 again. Suppose third that Y has the value set 1, 0, then Y is true, as well as false. But the truth schema, by the truth schema, the value set of Y is going to be unit set containing 0. So since Y has only one value set, 1, 0 equals 0, and so again 1 equals 0. So all three cases lead to triviality. So this looks like a revenge liar for the dialetheist, and there's much more to say about that, but I think at least we shouldn't expect the dialetheist to escape the challenge of revenge. This is an example that poses a problem. Given the time, I was going to say more about the back and forth one might have about this dialetheist revenge, but let me, maybe we can do that in the discussion. So let me return to the singularity theory and quickly say something about how it might respond to this kind of revenge challenge. Okay, so revenge is a challenge for the singularity theory too. Let me sketch the way in which the singularity theory responds to the challenge. To fix ideas, start with a fragment of English that contains no semantic terms. We obtain the language L by adding the English predicate true. And we can do the parallel thing for denotation and extension. L is the language, L, this is English plus English, fragment of English without any semantics plus, say, the truth predicate. L is the language that the singularity theory is a theory of. And if we're dealing with denotation, we'll add the denotes predicate and develop the theory there. The key claim here is that the language in which the singularity theory is couched and called the language of the theory T, it's not a Tarskian meta-language for L. A full defence of this claim would require a much more detailed account of the singularity theory, but maybe I can indicate the broad outlines. The job of the singularity theory is to identify singularities of a given occurrence of true. This is done via the primary trees. The resources needed for this are relatively meagre. We need only the determination set for a given expression and information about whether or not a context is explicitly reflective with respect to a given expression. Given these, we can define the notions of primary tree and singularity. Nowhere does the language T of the theory contain a predicate coextensive with any occurrence of true. The theory doesn't provide a model of English. Rather, it provides the means for identifying singularities of a given occurrence of true. So T is not a meta-language. The language of the theory is not a meta-language for the object language L. However, it's natural to go further and provide glosses on the theory that make the context sensitivity explicit. With the singularity treatment in mind, say, of the liar sentence L, we should be able to say explicitly that L is not true in context alpha, but true in the reflective context RL. And we should be able to say that L is true in some contexts, but not in others. Recanati points out that small is an indexical, but we can make the comparison class explicit, small for an elephant, and then the expression no longer functions as an indexical. Similarly, true is context sensitive. It's sensitive to the standards of evaluation that are operative in a given context, but we can make those standards explicit. For example, true in the reflective context RL. The predicate true is like small or hexagonal or flat in that it can be used as a context-sensitive expression or as part of a decontextualized complex term. So true and denotes an extension are not narrow indexicals, if by narrow indexicals we mean indexicals that are non-bindable. So suppose we consider all the sentences of L that are true in some context. Let's introduce true sub L to abbreviate the phrase sentence of L that is true in some context. We can think of this predicate as the truth predicate for L. It applies to 2 plus 2 equals 4 and to the liar sentence L, and in general to any sentence of L that is true in some context. Suppose we add true sub L to the language T of the theory. Call this language T plus. Okay, so T plus is the language of the theory plus this predicate true sub L. Now there are certain things that can be said in T plus that cannot be said in L on pain of paradox. That's because every occurrence of true in L has singularities. As we saw, we can always construct anaphoric liars. And these singularities will be true in some suitably reflective context, so they will be true sub L. So true sub L in this way will apply more broadly, than any given occurrence of true, because that occurrence of true will have singularities that true sub L can apply to. So in this way, T plus is expressively richer than L. But in other ways, L is richer than T plus. T plus is a restricted theoretical language, free of context-sensitive terms, and since its sentences are not identified as singularities, every occurrence of true will have sentences of T plus in its scope. Since we can regard T plus as a classical formal language, it's subject to Tasker's theorem, and a Taskin hierarchy can be generated from it. But since none of the theoretical sentences in this hierarchy are identified as singularities of true, the scope of the truth predicate of the object language L arches over not only T plus, but the languages of the hierarchy. So in this strong sense, L is expressively richer than T plus. So, just finishing up, suppose again that you're omniscient and you say snow is white is true. Suppose your task is to lay out the extension of your use of true. You know that your use of true has singularities. It's always possible to produce an anaphoric liar. But you know that in other contexts there are true reflections on this liar, and you can throw these true reflections into the extension of your use of true. And since you're familiar with the singularity theory, you know that this anaphoric liar is true sub I. That is true in some true sub L rather. That is true in some context. And this context-independent truth, that the last sentence is true sub L, can be thrown into the extension as well. And so can the truths of the language T plus and the truths of the hierarchy generated from T plus. A decontextualized truth predicate, I want to say, doesn't compromise the singularity theory. Rather, it provides more truths to be included in the extension of an ordinary use of true. A given use of true or denotation or extension is almost global and applies almost everywhere except to its singularities, but this expressive incompleteness is minimal and local. The singularities it fails to evaluate can always be evaluated elsewhere. That's it.